can't see the students now.
They can see us.
Yes.
Hello and welcome to our live chat. Now, I hope many of you have already logged in and others may be logging in. I welcome you all. I am Dr. Mutkavi sitting at the center. To my right is Rajiv Mutkavi. He is my technical assistant. He is our technical assistant. And on my left is Tulsi. She is another technical assistant who have helped me prepare the sessions and prepare the PPTs and corresponded with you. I think almost all of you are aware of the things what I have taught you. And let us have a live chat. And this is a sort of interaction between you and us. I am extremely happy to have you as my students. And not only now, but you can call me anytime. In my first lecture, in my first PPT also, I had given you my name, my telephone number, and then my mobile number and all other things. Anytime you have a difficulty, please do call me. You can contact me by email also. And also, I would like to tell you that in future, I am planning to give you a couple of more programs based on electrochemical sensors for pollution monitoring and chromatography for pollution monitoring. I hope all of you will be joining us whenever we launch that program. That will be shortly either next semester or next to next semester. Right now, we are about to start and finish off this infrared spectroscopy. So I would like your introduction as well as questions if you have any, and then we'll take it up from there. Any help you need, we are ready to do that. Is it all right?
I think what we can start off is looking at the existing questions as well, answer them, and by the time some other questions are available, then we can answer this.
I can do that. Actually, we had a lot. How is this changing?
There's a bit of delay, so don't worry
Okay.
about it. Yeah.
Actually, I have had number of sessions regarding and including your questions. I had a look at some of them, and about 6 or 7 of them were there for our interaction. And then now I will go through some of them and my response also. In between, if you need anything, you can type something, or Rajiv also can give you inputs as and when we require. Now, the first name that comes to me is Mr. Tangagiri B. He has asked me how to quantify more than one metals in the air pollutant. Is there any technique available? So actually, the English is very bad. It doesn't matter. It is not stated properly and doesn't make much sense, because what you want to know, Mr. Tangagiri, is how to quantify more than one metal in the air pollution, in the air matrix. If I can make out what you have been asking me, that means you are assuming that there are a lot of metals in the air, and the metals could be in the form of the vapor, or it could have been deposited on the metals. It could have been being carried out of the air matrix into the environment, onto the soil, onto the water, etc., etc. That's what you want to know. So, given a matrix of air, assuming that there are a lot of dust particles and metals also, is there any way or any technique available to estimate all of them simultaneously or something like that? Basically, the question is not clear. So the idea is, uh, even if I answer at this stage exactly what you need, I may not be able to address. So it is very important for all of you to ask the right question, and then be focused exactly what you want. Now I assume that I'm going to cut your question into three different parts. One is how to quantify more than one metal in the air pollutant, air pollution. It should not be pollutant, but many of them are pollutants only, because any element of the periodic table, in my opinion, in excess is a pollutant. Okay. So we assume that there are a lot of metals in the air. That is a correct assumption. There will be calcium, there will be magnesium, there will be other elements like beryllium. They are all in the air. And then many of the metals are in vapor form also. For example, mercury will be already there, because mercury has got a vapor pressure of about zero point 0.3 uh, 0.31 or 32 millimeter pressure in the air. So that is why we do not like any mercury being spilled on the floor of the laboratory.
Also, if you can answer that from an engineering perspective,
I
he
will
comes
ask
from an
you.
engineering
Yeah, yeah,
background,
yeah.
so you might be asking in an industrial setting.
I will answer that also. That is why I have to assume that you are asking, you are the question what you are asking and what I am answering are matching. Okay, because it's not written exactly. So let us say that we have many elements in the environment, and some of them could be in the vapor form, which are distributed uniformly uh, all over the air matrix, in stratosphere, etc. Or there could be uh, metal vapor coming into the environment, which will get absorbed onto the dust particles, silica. And then whenever take a sample of air through air sampler, all those dust particles are going to come onto the platform, and I can dissolve those dust particles, silica, using appropriate methods to dissolve. For example, if I have to dissolve the silica, I will have to add HF. So non-silica materials like nitrates, sulfates, etc., calcium, magnesium, and all these things, I have to dissolve them just in acid. So depending upon the metal element that we want to estimate, we will be able to estimate whatever is the element in the air. Now, there are not many elements in the air which are really, they will remain in the air. It's not like that. They get settled down. But at a given time, in a given matrix, there will be always certain amount of metal element. Okay, and these metallic elements are in the form of ions adsorbed onto the metal whenever I make a sample. So the air pollution sampling normally involves drawing of a given matrix of air through a filter paper and collecting the dust through the filter paper. There are different standards available how to collect a sample, how much air to pass, what should be the speed, what is the total amount of air to be collected, like that. And we will have to correlate all those aspects and then determine the element in its totality. It could be in different species. For example, mercury can exist as mercury vapor, mercury ion, Hg plus, and Hg2 plus. Okay. Silver. Silver is also a very toxic element as long as it is there in the air. So silver also can be in the form of a metallic element silver, or it could be a silver ion. Silver ions are more toxic than the metallic silver atoms. So when you collect the air sample, normally what happens is we are collecting almost all of them into the onto the solid particles of the dust that is being collected through that. Now coming to the analysis, what is the second part? The second part I am thinking, is there any technique available? I have in this aspect, I should tell you that the techniques for metallic elements analysis are varied. You can extract them from the dust into straight away into an absorbing solution, and then add your analytical reagent, give a colored complex formation, and the color complex can be estimated using spectrophotometry. So this I have taught you in my very first NPTEL lecture, that is on spectrophotometry. It is available in the YouTube, NPTEL, everywhere. You can take a look at it. And then suppose the element is not in milligrams or in grams, but in micrograms, then the technique preferred technique will change. So the preferred technique, what you would be going for, what you would be needing, if it is still smaller quantity, you need atomic absorption or inductive coupled plasma atomic emission spectrometry. And then there are different ways of doing several elements, dedicated elements. For example, mercury, there is only, you don't need an atomic absorption instrument. Just for about 2 lakhs, there is a mercury determination unit is available based on the simple atomic absorption principle. And there are different methods. So depending upon the concentration, whether it is microgram or milligram or nanogram, or it is uh, picogram or femtogram, depends upon the technique. They are available and you will have to learn about it. I have most optimum way of determining these metallic elements in parts per million and parts per billion level. That is where our concern currently is. Atomic absorption, ICP, and spectrophotometry. These are the techniques available for the determination of metals. And each element is a separate chemistry by itself. That is number one you have to understand. And each technique is a separate entity. For example, the sample preparation changes from atomic absorption to ICP or spectrophotometry. There are different ways of doing it. I have covered most of them in my previous courses. You may go through them, and if you have any difficulty, please do get back to me or to Rajiv or Tulsi. Okay, you can, Rajiv, you want to say something about this?
Yeah. Regarding this question, it would be more clear if you could state your background and the environment through which you're asking this question. For example, are you asking this from a regular pollution on the roads, or are you asking from an industrial environment point of view, etc.? So it'll be a little more clearer in the question which you want to ask. Write a little more in detail. It'll help us to answer your question more clearly.
Also, it makes a lot of sense to say a little about yourself so that I can understand, I can answer to the point as a, but there is another selfish motive as far as I am concerned. That is, others also will learn from your questions. That is important, because whenever I have to learn something, I need not learn it only from me and my teacher. There will be other students asking similar questions. Let's learn from them also. So if you state your background, that also would be very nice. Thank you. Let's continue.
Let's look at the second question. Tulsi, can you just state the question?
Can you read the question, Tulsi?
I have a request for feedback, not question. Many questions given in assignments are ambiguous. I request the course organizing team to please address this.
Can you be a little more louder, please?
We are still learning the topic and it doesn't help when the questions are not clear.
Okay, I think that is a fairly relevant question. First of all, you have to understand that there is no way for you to understand a topic whenever it is ambiguous. There is no better way. If the moment you feel it is ambiguous, it's not very clear, then your mind will start working, which is correct, which is wrong. which is why it is not clear like that. So, especially if you have an open-ended examination at the end, the questions are not given from the text where you can find the answers. You have to glean the correct answer from the text and then make your answer up there when you are writing the exam and then incorporate. Now, there could be some certain amount of ambiguity, and you have 1 month time to contact me. Sir, this is not clear. This sentence is not clear. This uh, this point, which is there in the PPT or in the lecture at such minute, 23rd minute of this lecture, is not clear. Like that, if you can suggest to me, I will go back and explain to you. Okay. So the ambiguity is not sort of, it's not ignorance, but sometimes the ambiguity also can come because of your understanding also. So if you are specific about an ambiguity, you should stop me and ask me. Now, obviously, we are in contact with each other. Two technical assistants are there, I am there, and our phone numbers are there, our emails are there. Definitely, please do contact us if you have any difficulty. Is it okay with you? Yeah? You want to say something?
Yeah. So when you feel that the questions are ambiguous, kindly write to us. We will be able to answer your query quickly in a day or two. And also, as Professor mentioned, kindly indicate the time where you felt the question was ambiguous, and also write to us when the questions are not clear. I think, yeah. Can go on to the next question.
Shall we move on to the next question then? Okay. Rajiv?
Shobhana Purushottam asks whether some advancements in analytical methods are present. Again, the question is not very clear. I think we can take this up with the student personally. It's not very clear. The Ravindra Kumar asks, can we use spectroscopy for determining all types of pollution, air, water, soil caused by metals, non-metals, and semi-metals? It's a very open-ended question.
Let me get back to you from the third question, Shobhana's. Shobhana, I want to tell you that your question is, I would ask some of the advancements in analytical methods. My God, there are many advancements, and the basic requirement is you should be specializing in particular area. Then only you will be able to obtain some amount of make some sense out of the advancements. But for routine analysis, as far as pollution control is concerned, the requirements are specific, and the methods what I have been teaching you, that is spectrophotometry, ICP, atomic absorption, cold vapor mercury, and then this hydride generation, and all these techniques are good advancements only, because many of them can give you analysis capabilities of the order of about 10 raised to minus 12 grams. That is picogram level, quantitatively. It's not qualitative. So there are definitely advancements, and there are certain journals which you can refer to. For example, analytical chemistry is one of them, and then spectroscopic techniques are there, or journals are there. They will be giving you the state-of-the-art advancements in the determination of many metals. Okay, and in analytical methods also. Among the analytical methods, we are discussing only the metals so far. But this course is regarding infrared, where we can handle even the organic compounds in the air as well as in the other matrix. So my answer to you, Shobhana, is there are several advancements in analytical methods, and they are all relevant. For example, if one of your friends or somebody if anybody in the population is suffering from Alzheimer's, okay, disease, then there is a requirement of the determination of aluminum in femtogram level or 10 raised to minus 12 gram level Okay, femto is not 10 raised to minus 12 pico. Femto is 10 raised to minus 15. But the femtogram qualitative refers to picogram quantitative. Okay, so that is the connection. If your detection limit is in nanogram, then your estimation, quantitative estimation range would be in micrograms. Picogram to nanogram, quantitative determination, and nanogram to microgram. And if you are in microgram, you should be able to determine the quantitative aspects in milligram level. So there is always certain amount of give and take, because detection limit would be approximately 100 to 1000 times lower than the quantitative determination level.
Yeah, that's right.
Okay. So we always talk of detection level and determination level. Now, the next one, I don't know, Shobana, you have to tell me whether I have satisfied your question. And we can again take this dialogue further as and when you need more information, and we will take it up. Okay. The next question Dr. Rajiv has given me is, can we use spectroscopy for determining all types of pollution caused by metals, non-metals, and semi-metals? My God, this is a fantastic question. Okay. The point is, uh, the
I think he means IR spectroscopy here.
I don't know. I don't know. The question is again very broad. That covers metals, non-metals, and semi-metals. And the spectroscopy also. Uh, okay, it says spectroscopy, and spectroscopy can be anything. Infrared, IR, infrared, far infrared, near infrared, and then microwave, ESR, Raman spectra, and so many other things, molecular spectra, UV visible, all those things are covered in this, Mossbar spectra. But the answer is, again, if I have to refer to your question and answer is always yes, we can. Now, the remaining part of the question is pollution, air, water, and soil. Answer is again yes. Pollution can be either in the form of air pollution or water pollution or soil pollution. It may be localized or it may be general. For example, the carbon dioxide pollution. Carbon dioxide is not basically a pollutant. It only increases the Earth's temperature by abstracting the heat into the elastic adsorption of the infrared frequency, thereby increasing the temperature. So it increases the temperature in that aspect. In that respect, it's not environment friendly, but it's not a pollutant. Carbon monoxide, yes, it is a pollutant. So what are we talking about? We are talking about air, we are talking about water, we are talking about soil. So air could be homogeneous, water could be homogeneous or could not be homogeneous. And soil definitely not homogeneous at all. For example, if you want to determine particular elements in a 5-acre land, let us say, then what happens? If you take a sample from one corner and take from the another sample from another corner, opposite corner, you will never get the same element matrix exactly in the same concentration. Then what do you do? Do you throw the analysis out of the room, out of the report? No, you have to accept it, because soil is a heterogeneous matrix, whereas air and water could be homogeneous. There is another way to look at it. For example, if I have to uh, look at pollution in a particular specific area, that is known as localized pollution. A river stretch like our Ganga, it can be polluted near Kashi. It can be polluted near Varanasi, Kanpur, yes, but it need not be polluted in Haridwar or still higher up. But down the line, it may be polluted, or down the line, it may be purified also. It depends upon how much it is exposed to the air, water, sunshine, removal of the pollutants, and all those things are to be considered. So the answer to your question, Ravindra, is yes for all. we can use spectroscopy. There are spectroscopic techniques for different types of pollutions which can be applied to air, water, and soil. They can be caused by metals, non-metals, as well as semi-metals, and organic compounds also. Yeah, you have not written this, but I am going to tell you that many organic compounds which are synthetic and natural also, that is methane is one of the natural ones, and all these things can be analyzed, can be monitored by spectroscopy. And now when I say spectroscopy, I mean general term for spectroscopy, not exactly one thing. Can you read the next one, Tulsi? Yeah.
Ravindra Kumar again asks, what is difference between beta particles and beta emissions?
Ah, the I think Ravindra Kumar is again. It's a
good question.
Good question. Most of the radiations coming from the metallic elements are alpha rays, beta rays, and gamma rays. Alpha, beta, and gamma. Alpha rays are photons being emitted, or the helium atoms, 2He4. If helium atoms are coming out, they are known as alpha rays. And the alpha rays are composed of helium atoms. And then beta emissions. Beta emissions and beta rays, or whatever it is, we call it essentially same. So beta rays and beta emissions are same.
He's asking
And
beta particles.
I'm coming to that. I'm coming to that. Beta emissions and beta rays.
Right.
I am
Beta
saying both are
particles.
same.
Right.
Okay. Now, in beta emissions, the electrons are being emitted,
All positrons.
or positrons, mostly
Electrons.
electrons. Okay. So there is nothing like beta particle. It is an electron streaming, coming out of a stream of the in a stream from an element which is having the atomic structure which cannot sustain the neutrality, so it has to eliminate one electron every time from one of the nucleus. So in beta rays, beta emissions, only electrons are being emitted. Now, does it answer your question? Gamma rays again.
I think the question can be taken more in detail again if he explains it more clearly.
Yeah, that also we can do that. But if you need it, definitely we will take it up. But for you, as far as you are concerned, Ravindra, beta rays are particles of electrons. Electrons coming out of a radioactive substance is known as beta rays. What is the next one, Raj?
The next one is
Sunil Abraham. No?
Stanley Abraham.
Stanley
asks,
Abraham.
What are the equipments which can be combined with this equipment? I think he means the IR or FTIR.
No. Stanley, that makes a lot of sense. I did talk about this in my last class. There, what I had told you is IR can be combined with several other techniques. They are known as hyphenated techniques. Okay. These hyphenated techniques are simply, two techniques being combined. For example, GC-IR, gas chromatography connected with infrared detector is GCIR. Okay. Similarly, mass spectrometry. Mass spectrometry, what does it do? A mass spectrometer separates different molecular ions, and those molecular ions can be detected by IR, or they can be detected by their any other property like refractive index or its molecular weight or whatever it is. So the answer is, what are the equipments that can be combined? GC and HPLC, mass spectrometry. These three come to my mind immediately. And these such systems are available in the market. Okay, you could buy them and you can use them. It depends upon the detector part, what you want actually. Okay, so you want to know what are the functional groups in the separated compounds. like GC or mass spectrometry, you are most welcome to go for determination using IR detector. So that is GCIR, MSIR, mass spectrometry IR, HPLC IR. These three beautiful techniques.
Okay. Next question is: I missed my two assignments. Can I attempt the next two, and will I be eligible to appear for the examination?
Yes, this is a very good question. We have already discussed with Rajiv and I discussed with our team in institute also.
Yeah, so the team in NPTEL suggests that you can definitely go and attempt your two remaining two assignments.
But you do try.
But I think you'll be scored or evaluated for the only assignments which you have attempted for. Yes.
It will be there.
And since it comprises only about 25%, you still have a good chance of scoring well in your final exam.
Yes, but you have to inform the Madras office, NPTEL, as well as the Bangalore office. Okay, the NPTEL.
Yeah, I think you can write to them.
You will have to write to them, and I will also endorse if you are interested in writing those two assignments. Actually, assignments will give you enough mental exercise to understand the subject. That is why quite often I make them sort of ambiguous also. So you should know for any given question, there could be several answers. You should not miss them. That is the whole idea. The idea of this NPTEL lecture, MOOC lecture, is to let you know that there can be different answers for the same question. All of them could be correct also. So please keep an open mind. Okay.
Okay.
Next one.
Yogesh Chandra Sharma from VIT asks, how can we monitor air pollution using this technique? I think that's the whole course.
How can Yogesh Chandra Sharma, Purnima Nag?
Yeah, that's the question.
Oh, Purnima Nag, we have already answered. Correct. So Yogesh Chandra Sharma asks how we can monitor air pollution using this technique.
I think he means to ask.
You mean IR?
IR.
Infrared.
That technique's already established in the field, I think.
Yes, even infrared is well established in the field. If you listen to my last 2 or 3 lectures in this program, I will be covering that in my recordings. And for the time being, I can tell you a couple of instances where such questions can be, where such applications are relevant. You just imagine you have petrochemical complex, lot of petrochemical gas is coming and gas is being cracked, hydrocarbons and then aldehydes, ketones, petrol vehicles and many other things are coming in the environment. They could be being emitted also. And if I just put a probe there for at the top of the chimney stack, then I can collect the sample, bring it, transfer the sample to my lab, and then get it analyzed. The whole thing can be made online. So online infrared monitors are already available in the market. They are already being practiced in many petrochemical industries, and also there are couple of things like VOCs in the air environment, not necessarily in the refineries, but even in many towns nowadays we are monitoring VOC, volatile organic compounds. For additional characterization of the VOC, we need IR. Okay, so sometimes we go for VOC means methane hydrocarbons and non-methane hydrocarbons. So more methane hydrocarbons, as I told you, they are all amenable for analysis by infrared spectroscopy. And the other non-methane also definitely yes. The current answer is like this. Okay. So if I have covered your answer, if you are satisfied, I will also be satisfied. You need more, please keep in touch. Have some patience. In the last 2-3 lectures, all these things will be covered wonderfully. Thank you.
The last question from there now. Tulsi, you can just.
Tulsi, what is the last question?
Mansha Kushu is asking. He has a doubt in assignment 3 questions 2 and 5.
assignment 3. Assignment 3, is it?
Assignment 3, question 2 and
I don't know
So the
what is
question,
2.5, Raj.
No, I think she means question number 2, question number 5. What is the primary angle in degrees at which a radiation of 300 nanometers is diffracted at a normal incident by a grating ruled at 1080 grooves per mm in the first order? I think this is, if Mansa, are you facing difficulty in answering this question, then you can raise a query against it, or be a little more clearer in what question you're trying to answer. And I think your question number 5, stretching frequencies occurs in series. Now, this is loaded into a different editor called text. So let us know if you're able to read the text format in your computer. If not, then it can be sent to you separately, or it can be addressed as a general statement for all people. So I think that answers your question. There are some more questions. Probably that's the end of the questions which are addressed to this live interactive session. Any more questions? Some more questions which I would like to take it up for the benefit of the students are given in this. So one of the students.
These are the questions asked to us over a period of time. So we have prepared the answers for your benefit.
So some of the questions asked are like this. Sir, I have watched both the videos of week 1. By watching video, I could answer only 2 assignment questions. How to answer for the remaining questions? Kindly ask the questions at least 75% from the videos of materials.
No, the answer is no. I will not be asking questions from the PPT material because that is obvious. Now when I want you to learn the subject, I would be
wants them to
NPTEL wants you to study the topic. There are reference books given, and reference books will cover it in more detail, whereas my PPTs will only convey to you what I want to convey. But people, if you listen to my lecture, there will be much more. With the same PPT, I will be explaining longer. Okay. So I expect assignments are meant for you because you have enough time to study and then come to the answer. So assignment questions will not come definitely from the PPTs, but the assignment questions can be repeated in the final exam. So if you attempt them seriously, you will not have any difficulty in clearing the examination with good marks. Okay, that's what it means. Okay. We want you to learn. That is why we give you assignments which you may not find the answer. You will have to go to the reference books and study what I have taught, what has not been taught. You will definitely find them there. I have not gone out of the books which I have suggested to you as reference. Okay. I think that covers your question. Any other one? Rajiv?
No, I think just a pair of queries which have raised up. One of the student, Kavita, asked, respected sir, in assignment 1, question number 4, beta particle are negative charge and the answer is B. So assignment 1.
Let us see that.
This is the assignment 1. Question number 4. Beta particles are negatively charged. So the beta particle question.
Yes.
So the correct answer is mass and positive charge is given as a correct answer, accepted answer. I think this is a correction from our end. We'll have to see.
Mass and no charge. Beta particles.
It is incorrectly
mass and negative charge is correct.
That's the correct answer, but the correct answer accepted is given as this. So I think Kavita has a point here.
Mass and negative charge it should be.
Yeah, so we'll have to neglect that question from the scoring.
Yeah, we will neglect that. Correct answer is mass and negative charge, beta particles. Definitely. It's a typographical error could be, but definitely confusing. Correct answer is mass and negative charge, because electrons also have mass. Okay. Thank you very much for pointing it out. We will take care of that.
I think
Next
Purnima.
one.
No wait, Purnima has come online.
Purnima.
Yeah. That is the last question she asked. Yeah, Purnima
What is
from
she?
Jaipur.
Hmm.
She had asked that questions.
Where is her question? Purnima, can you type your question?
I think
She's the
texting
one
will
who
be
asked.
easier.
Okay.
And this might do assignment.
No. Purnima wants some specific question, I think.
She is not typing anything.
Purnima, are you able to follow the live show?
So we have to answer her question.
No, it's
No need.
answered. That will be available to her. But
Apart from these questions, if any of you who have already logged in, you have any questions, please come on chat. We will be able to answer whatever your queries are. We will take it up from there.
so
Abhishek here. Abhishek, you are welcome. Yeah, this I have already answered.
Yeah, Purnima, I think your question has been taken up and answered. You are eligible to appear the exams. Yes, that is right. So if there are any other questions, please ask them on the chat box now. Otherwise, we'll be ending this in 2 minutes.
Oh, you are most welcome, Abhishek.
That will go on a loop if you keep on doing that. So Kashi Rajan has a point.
Which has high energy?
Can I have
X-ray or gamma ray? Oh, wonderful.
No, he had a point here which was taken up. Question number 9 in assignment 1. I think it is again incorrectly marked as the energy of gamma rays are same as X-rays, less than X-rays, greater than X-rays, and none of these. The answer, accepted answer has become as less than X-rays, which is incorrect, I think. So he also has a point that the question, energy of gamma rays are definitely more than X-rays, Kashi Rajan. So your point is noted. We'll see what we can do about that question. That can be neglected.
We will correct it. Either we will correct it or disregard it. The correct answer is energy of the gamma rays is much more than X-rays. If I remember the spectrochemical figure, what I have given you, electromagnetic spectrum, first comes gamma cosmic rays, then gamma rays, then X-rays, all in terms of energy. So it just doesn't make sense to say that gamma rays have more energy than X-rays. The other way around is correct.
Aishwarya Nambiar also had the same question.
Yes. Aishwarya Nambiar, ditto answer.
So Abhishek, can you just state which question number, which assignment?
Please hurry up. We have only 2 minutes. Related to nuclei with even neutrons, even after the correction was shared.
I think I know this question.
The question was not clear. Oh,
I know this.
I see.
Assignment 2.
Was it in assignment 2?
Assignment 1. Which he has mentioned it as assignment 1.
Assignment 1 is it?
Where is assignment 1? Here it is.
There are 2 more questions.
2 more are there?
Yeah. So Subhash.
Prakash.
Cosmic, Prakash.
No, the
One is Subhashini
previous to
Krishna.
that, Subhashini Krishna. How
Subhash.
many assignment is required for exam?
Out
Right.
of the four assignments which are given, three are to be scored for the examination. I think
Best of three, I
best
think.
of three.
Is there
Okay.
any text notes?
This text notes. I always wanted to tell you that whatever text notes are there in the PPT, they are the best text notes. Anything else I have said is either is in support of those sentences, or you can print them out, screenshots, and take the thing. We are also trying to upload text notes if it is possible. Okay.
Abhishek's
As of
yeah.
now, there are no text notes. If you want, we will upload them. But it is already there in the form of lectures, no?
Okay.
Before that,
Was there one
There
more
are-
we have
question?
missed Prirag Prakash's question.
What is that?
Is there anything that have more energy than gamma ray?
Gamma rays.
Cosmic. I have already answered that. Cosmic rays are having still higher energies. So any cosmic rays that are coming from outer space are detected even in the about 4 or 5 kilometers below the Earth's surface. That is the logic.
Okay. One more question. I think Abhishek's question I found out. His question with elements with even nuclear charges are abundant,
Abundant, less
stable,
abundant,
have more isotopes, and none of this. I think there is a question and his clarification right now.
Answer is there in the text. And if you listen to my lecture, you will find it, Abhishek. I will not answer that here.
So I think Abhishek. I think Abhishek, we can take this offline again. I can ask you a question in more detail.
Okay. What is the next one?
A question from Shailesh Kumar.
Shailesh Kumar.
A polluted sample is to be analyzed by TIR. By chance contamination occurred. How to identify such contamination in the spectra?
By chance contamination occurred. How to identify such contamination in the spectra? Oh, Abhishek, no, Shailesh. It's very simple. In all spectroscopic techniques, you have to analyze a pure sample. If there is any deviation from a pure sample that is of spectroscopic grade, if there are any additional peaks or peaks are distorted or peaks are tailing, so many possibilities are there. If something like that happens, you will have to assume that there is some certain amount of contamination. Am I clear?
I think the next question is Subhashini Krishna again. My answer is correct in assignment Q1, Q number 4. That is a beta particle question. I think she has given the right answer, marked incorrectly. So I think she is asking the question.
Subhashini, if we will do the correct thing. Okay?
I think they're asking for some text note in PDF format.
We will try to upload it. Okay? If you are very serious about it, we will upload it. Otherwise, also you can have the same thing without my permission. Any screenshot of the PPT, you just collect them and you have all the text material in your possession.
Okay. If
anything else is there? So, if there are no questions, I would like to thank all of you. Okay, all of you for being part of our infrared family. I wish you all the best and thank you very much.
just a minute. I think just answer Devendra's question.
Devendra's question I would like to answer. There is a book known as Dyer, Infrared Spectroscopy. They are all given in the reference. In my first lecture itself is there in NPTEL course. All the reference materials are easily available. They are in the form of books.
Subhashini Krishna again asks, is there assignment 0 and new assignment added to the score? Subhashini Krishna, assignment 0 is not to be considered for the scoring
It will
purposes.
not be
And a
considered.
new assignment is not added. It has been removed from the course outline. So you just have assignment 1, assignment 2, 3, and 4, which will be evaluated for your final evaluation.
It's not necessary for you to do the assignment 0 also. You need not do it.
Write the reference.
Yeah,
Is that right?
I think so.
No.
There's one more question from Shailesh Kumar. Is it possible to create a handy FTIR like sensor to monitor pollution in the polluted site?
Very good question, yeah. Huh? It is possible to create a handy FTIR. It is possible. There are certain instruments available wherein total infrared radiation is taken, and the difference also is measured after I put a small sample. Okay, so the sample will absorb part of the radiation, and the remaining is just like Beer-Lambert's law. Okay, in incident radiation X, output radiation is Y. The difference is related to concentration. Such handy things are available, but I don't know about FTIR. Okay, FTIR is a different ball game. It may not be there, but you are most welcome to invent it.
Subhashini Krishna again asks,
Yeah.
for the final exam, what will be the question pattern? The question pattern, I'm
Is
not.
also put up on the NPTEL guidelines. For your benefit, I can say that there will be some questions from the assignments repeated, definitely about 40%, and some questions you will have to learn. But your answer will not be obvious, but you will have to think about it. And one or two questions based on the bond strength. Okay, what is that problems you had requested?
Which one? The bond strength questions regarding the
infrared spectroscopy,
yeah,
where we can expect a peak.
Exactly.
Okay, such questions are already there.
Also, just one important clarification before answering your final exam. In many of the questions, you are expected to write one particular wave number, which should fall in the correct range. So don't write the range in the answer. The answer will ask only for one answer, and just write the number only.
Okay, when we will get the answers for the assignment which is over. I think we will leave it to NPTEL administrators. They will get in touch with you.
Devendra Singh Solanki, I think regarding your question regarding the textbook, I think we can take it offline. I'll send you the details of the textbook.
All the reference books, we will send you a list. Okay. It is also there in the NPTEL first.
Yeah, two of them are there. I think
syllabus.
The diary is not there. I think that we can just
diary is not there.
Just put it up here later.
Okay, we'll put up the diary book for your reference.
So I think we can close this now.
Now, if there are no questions, I would like to thank all of you once again. Okay. So all the best and wish you all good learning. Thank you very much. Have a nice evening.
Right, I think we can close.
Right.